Obviously, as you can see, it says 6 protons and 6 neutrons, very tiny over there. That makes the nucleus. As you can see, carbon is in period 2, so it therefore has 2 shells. The electrons in atoms are stored in shells, obviously, since I already told you about that. So, as I said before, groups, columns of the table, all that stuff. So, the outermost shell is the shell corresponding to the row the atom/element is in. So if you have 1, so if you're in group 1, then you have 1 electron in the outer shell. Because obviously hydrogen only has 1 shell, so that's also its outermost shell. So carbon is in group 4 over here, see? Number 4. 1, 2, 3, 4. So it has 4 electrons in its outer shell, as you can see in the picture over here. So atomic bonding, forming molecules from atoms. Periodic table of course, means the properties of the atoms repeat from row to row. Atoms generally, quote unquote, they kind of have sort of feelings to fill their outer shells with electrons by interacting with other atoms, also known as bonding. And there are different types of bonding, which we'll explain later. So in period 1, hydrogen and helium, 2 electrons correspond to a full shell because there's only 2 atoms. So as we can see over here, let's just go back for a second. Actually, no, we're going to go back in a second. In rows 2 to 3, 8 electrons correspond to a full shell. Same number as the number of main groups in the periodic table. And we will talk about the other groups in later videos. So usually 8 electrons. So over here, these are our 8. These are our 8 quote unquote main periods. These guys, and in all of these 8 electrons corresponds. Well, usually in these guys, 8 electrons corresponds to a full outer shell. Actually, in all of the main columns, I believe. So, atomic bonding, covalent and ionic. Filling the outer shell can be achieved through chemical reactions where atoms react/interact through bonds to form new molecules. Atoms can fill their outer shells by either sharing electrons with other atoms, or giving up or taking electrons from other atoms. A covalent bond is basically, in short, when 2 bonds share a specific amount of electrons with each other. They can share 1 electron with each other, 2, or 3, which we'll see later. So, these guys, they're basically like, okay, sharing is caring. I'm too nice to take something from you, so we're going to share it with each other. So in ionic bonding, as we can see, one atom decides to lose an electron, and the other one wants to gain one. So take the example lithium fluoride. So over here, let's go back to the periodic table. So these guys, they all want to, usually all these atoms, they want all these atoms, yeah, they want to become like their corresponding noble gas in the same period. So carbon wants to become like neon, chlorine wants to become like argon, gallium wants to become like krypton, blah 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 blah, etc. We can also say nihonium, fluorovium, moscovium, livermorium, tennessine. They want to become like oganesson, right? Okay. So take lithium fluoride, for example. Lithium, it is very far away from its corresponding noble gas, which is neon, because it would have to bond itself so many times or make so many single bonds. But if it could just lose an electron, it would become like its neighbor, helium, which is number 2. Also, fluorine just needs 1 more electron to become like its corresponding gas, neon. These guys both have the same corresponding noble gas, by the way. That wasn't intentional. You don't have to have the same corresponding noble gas. But in lithium fluoride, lithium gives fluorine 1 atom, So therefore, lithium becomes like helium and fluorine becomes like neon. Okay, and that is the end of our first bonding lecture. Thank you so much for watching today.